This is our final result for our roller coaster polynomial, and we will show you how to make one. This is one of the relative minima of the graph. This is one of the relative maxima. There's another relative minima way down there, and another relative maxima up there.
Our x-intercepts are 10, a bounce at 70, 180, and 350. These points represent time on the x-axis.
To put these into a graphing calculator, you can set it up as x minus 10, x minus 70, x minus 70, x minus 180, and x minus 350.
Now that we have our points of intersection, we want to find the point that we can put in as the a value that will allow the roller coaster to begin at 250 feet. So we're going to start our equation as y equals a times our points We're going to plug in the point that we want the y to be at 0 and the 250. So that will start our roller coaster at 250 feet up. Now we must plug the point 0, 250 for the y back into the equation. We're going to times all of these numbers together, and the result becomes 250 equals our a value that we're trying to find times this gargantuan number. After dividing it out, we find the a value to equal this very, very small number.
You said you were close. You weren't exactly 250 on this.
And as long as we've done everything correctly, this will start our roller coaster at 250 feet in the air and perfectly at 0 on the x-axis.
These are the points from the original equation, and when you distribute them out, this is the equation you get.
After factoring out the original equation, this is the equation we get. After finding your equation, you plug in the a that you found before in for the a in this equation. By using synthetic division with each of the points, we can prove that they are all actual points of intersection of the equation. Now we see all 5 of the intercepts are proven using synthetic division.
The graph reaches from 0 on the x-axis all the way over to 350. The x-axis represents our seconds, so the ride will last 350 seconds. It starts at 0 to 50 here, but the x-axis is at 0. And it ends at 350 seconds along the x-axis here. So our practical domain of the equation is 0 to 350. The practical range of our graph is how high or low it goes on the y-axis. Our original point of origin is 0 and 250. The y point would be 250, because that's how high we are off the ground in feet when we start the roller coaster ride of our polynomial. while the practical range of the graph is 0 to 250, 0 being where it intersects the y-axis intersects the x-axis, the graph does extend below that.
The red area shows where the polynomial is decreasing, right here and here, and the blue indicates where the polynomial is increasing, here and here.
And that is how you make a polynomial roller coaster equation.
The end.
Indeed.